I'm edA-qa from edA-qa's room, and today I want to talk about dragging puzzles. So in my new game, I have a couple of puzzles involving dragging, like those little bits. You unfortunately going to see the game a bit. That's good, sneak preview. And you can drag bits around. They do deflections, they do like this, they can snap into places, and they hit the side of the borders here. So there's lots of things that dragging can do. There's also another one with books. I've got books over here. If you drag them around, they restack the books. These are two very basic techniques, but they let me introduce a whole bunch of different types of puzzles in the game, because previously I didn't have this. So now you can move items around, so stacking books as well as moving items. These will be collectible. And so that's the game, is that this is all done in HTML, JavaScript, with SVG as well as CSS. Technically I'm using TypeScript, not JavaScript. So there's lots of stuff involved here. It's not the easiest thing to get running, but I managed to work through it because there's a bunch of things to go through. And so today is going to be a little bit code heavy to go through it, but I'll show it around. But again, just to show off the individual features we're going to be looking at for. So this is drag and drop in the web. It's not, not entirely new, but this is an SVG object. So this is entirely vector graphics here. These little bits may actually not be entirely vector because I had to render some parts, but basically it's SVG, it's layered. So you can move them around and they're clipped to a frame. And that's one thing I'll show how it's done. And this clipping, of course, because this is all scalable, it doesn't matter what size this is, it all has to be relative to that. And again, nothing so extreme if you're new to graphics or if you're used to graphics programming, but to get this working with SVG was the point. I also have the clipping involved where it clips to the middle of an area, and minor deflections so items don't overlap. And again, in the books, I have them also constrained to an area. And this again is, of course, limited to the size. So it depends on the size where you go. And I want to go through now and show how all of this works. So we're going to start right from the beginning. Let's go to the easier one, actually. The deflection case is actually easier to understand, because it's a little bit more generic what happens, because when you move an object, it just stays there. So the key thing to drag and drop is that you have to handle the mouse going up and down. The API is relatively new. It's relatively screwy in JavaScript. There's some things that they changed on it, and it's not necessarily universal in the way that's applied. So I generally only test in Chrome and Firefox right now, but I know this basically works in Safari, but the rest of the game doesn't work in Safari because there's some defects in SVG, so I don't worry about it. So let's take a look at how this starts. I won't show how the structure of the game goes through so much in terms of the little bits, because that's a bit longer of a discussion of how that works. But let's start with one of these guys, ignoring everything else. This is an object here. And when you click on it, you can drag it. And this is actually literally an object. We can inspect the element, and it's this one above. This one happens to be an image, and it has this root element. And this is the one that's actually moved. So you can see the translate here, 415. If I move this down, you can look at the translation change in that debug session. So this is how I'm actually moving it around, is with the CSS attributes. Let's shrink that a little bit. I don't know if I can make that font any bigger, but so each of these objects, these are objects in my game, and they all end up in this prepare drag function. So prepare drag is called by my object loader. When I load this scene, it's going to go through, and for each of these objects, it's going to call prepare object. A few CSS elements, it sets an attribute like clickable and draggable. These set very minor things. They set click zones and stuff, and they change the cursor when you hover over them. These actually go to CSS classes, so they don't do that much other than set the CSS class, and then CSS is what does all the work there. Then I set up a context. Sorry. If you're familiar with JavaScript or TypeScript, you'll understand that this function becomes a closure, and so I can use this context to track data in this function. So I'm going to keep track of this. What I want to do to clean the pointer ID and the start position. The start position will come back to that, and the target, and that's the thing I'm actually moving, though, well, we'll get to that. Then I have a few other functions I'll get back to. Let's jump down to the one that's the most interesting right to start with. Sorry. is the pointer down. What happens when somebody presses the mouse button down? So this is like when you click on here, what's the first thing that happens before you move? And very standard setup stuff. So this is a normal HTML event. And I don't actually know the TypeScript type of it. There's some events there. I should actually put that in eventually. First thing is you prevent the default. And there's guys, it's going to click somewhere else and do something. I want to capture this. And I'm going to take the pointer ID. And this is, TypeScript doesn't really have this because it says pointer ID doesn't exist. And I think it's a newer one. So I just say, look, it's there. Pointer ID is actually there. And this might be the Safari issue. We have to look at something else, something that doesn't support pointer down correctly. In any case, this becomes like a 0, 1, or 2, depending on which mouse button you press. But it could literally be any number whatsoever. There's no guarantee about what it's actually going to be. Only that I actually have to keep track of it. And the starting position. Where am I starting from? So this is point like in the client X and Y, where am I starting from in this screen? And that's like where I clicked. Now this would be important because you notice when I move it always smoothly. So if I move only 2 pixels, it moves, it doesn't matter where I click on it, I only move 2 pixels. Or I only move the amount the mouse actually moves. And this is important for the user experience. Not that if you click on the side, suddenly it jumps to the center or something. That's why I track the start position, because you'll see I move relative to the start position. Now we can get to the first bit, tricky bit here, is the container transform point. The container is set up originally, and that's right here. I actually don't set it up in each call. It's just stored in this scene. And the container knows the SVG and stuff. And this is this class up here. There's a container class, object drag container, that is created. And this actually tracks the SVG. Now there's a couple things that happen in its constructor. Other than the tracking, it also tracks, it creates an SVG point. I'm going to use this many times because we have to store the point. So the first thing we did is we said when you click the mouse button down, I have to transform the point, and I have to transform it into the realm of the SVG, because the point in HTML is going to be the point I click in this entire area of the browser. But only part of this is my SVG, and I want everything relative to the SVG. And you can see it right here. Here is the SVG part of the screen. It's missing a little bit on the side. But more importantly, I actually want to track into the viewport. There's some viewport operations here because this is actually not this shape. This is a bit smaller in shape because you can notice if I clean it off here, it clips off the edges, but it's still the same shape. And so what's not being highlighted here, if I try to get the first group maybe, here's effectively the first layer, and this is effectively the viewport of the SVG, and I want to translate into that viewport. And so the way I'm going to do is I'm going to take the client X and Y, this is the event position that it gave me, and I'm going to use a matrix transform function from the SVG point, and I'm going to use this get screen CTM, and this is the transform matrix that says from the SVG's viewport to the screen. But I'm going backwards now. I have a screen point and I want to go backwards into the viewport of the SVG, so I call the inverse of it. In TypeScript, I put this exclamation here because for whatever reason, this could in theory return null, but the thing's screwed anyways at this point. So I might as well just take the exception and call inverse. And then I do matrix transform. And this is why I created the SVG point. Is because I needed to call this matrix transform function on it. So this is just standard graphics math at this point. I have a matrix from the screen, or from my viewport to the screen. I invert that, multiply it, and this takes this screen point and returns it as a viewport point, which I can now use to compare objects inside of there. It'll be consistent with my viewport, and my viewport's always 1,000 by something, or something by 1,000, but that's actually not relevant. And then I set the target to be the container that I'm in. I actually not clear on why I set this target anymore. It's not really so important. I just checked that it's SVG. That's just a technical detail. And then I get the bounding box of the target. That's the area that is collapsed inside of. And so I get the bounding max of the target, and I set this to the bounds. And I'm going to use that for the clipping movement. And then we'll just set this up. There's something called an anchor pad as well. The anchor pad is if the middle of this object is the object, then there's padding on all sides to determine when it goes to the edge. I have to know relative to the position of the object, what is the padding so it doesn't go outside? Not that if it was the center point that it would slide slightly over and go off to the side. And then I do a few other setups. I'm going to listen to the pointer move, pointer up, and pointer cancel. The most important part here is a set pointer capture. And this ensures that if somebody grabs it and moves off of the browser, I still have it captured. Not that I lose it. And it doesn't matter where they click away, I capture it. And there's also a pointer cancel. You have to watch that. Pointer cancel happens sometimes if somebody presses like Alt-Tab away, they've canceled the pointer. You may not get a mouse up. You can't be guaranteed to get a mouse up event. So anytime you track a pointer down, anytime you get a pointer down and do set pointer capture, it's vitally important that you do capture a pointer cancel as well, because this will be called. It's not just a theoretical thing. There are numerous cases where you will actually have pointer cancel called if they minimize it, if they switch a tab, if something pops up, if the browser just decides it doesn't want it, if there's a navigation event. There's all sorts of reasons, and you actually want to make sure that you cancel the pointer capture. Don't be one of those pages that keeps the capture on and then makes it super hard to work with the rest of the site. But knowing that cancel is called, you can usually Alt-Tab away and break the listening. And just a few more CSS things. I'll get back to one of them. Didn't actually work. Actually, this is the one right here. We'll get back to this one in the stack of why I do this. And the clean function just says, when I'm done on the pointer up, this is all the stuff I can do. And basically, I undo all of it here. This could be a function outside of it, but the reason I set it up here is because then I can keep track in the code. It's very simple to see. Anything I do here has to go into this list here. And so this is basically the pointer down. The pointer down event is just all set up. And the most important one is, where am I coming from? And what is the size of the area I'm going into? So let's jump over to the mouse move now event, or pointer move. And unfortunately, I still have the old names of mouse move. Guess there's developed this is the pointer move event. First thing it does is, again, it's called this CurrentPoint function, and that transforms it. Now, CurrentPoint does more than transform point. If you look at CurrentPoint, the first thing it does is transform into the viewport space of the SVG, which is what we did before on the pointer down. Translate the move event into the viewport of what we want. So somewhere in this area, into the relative coordinates of this area. And the relative coordinates include the scaling of this. So as this gets smaller, this is a range of a 0 to 1,000 at the top. And it doesn't matter what size it is or what position. When I translate the coordinates, it's going to end up being in that 1,000 space. And you can see that when I move this here. If we inspect this element again, if we look at, you can look at the translation down here. So it's 384. And of course, this doesn't change as you change the screen. And as I move this, you can see the translation at the bottom go up and down, and it's constrained to this range, and it's a bit less than 1,000 because there's some area at the top and bottom, but that range doesn't change when I change the scale. And that's the important thing. This is why we translate the points, so we have it relative to this viewport here. And if you have any questions while I'm doing this, please just ask and I'll try to answer them. So when you move, the first thing I do is I take this current point and this transforms the point. We did that before. And now the important part is the diff. This is the tracking from the start position. How far have I moved from where I've started? And then this will be the difference between the base. The base is where the object was when it started. This is the current position, actually. This is what I have stored. This is stored in another part of the program, but just assume this is storing the position. This is another thing I get into one day. And I add the difference to that base to figure out where I am. And then I call a clamping function. But let me explain that difference here first. I said that once before. The reason I track the difference is because it shouldn't matter where in the circle the user starts dragging. It shouldn't jump around. So if I drag the bottom, it should be like I'm moving the bottom around. If I click the top, it's like I'm moving from the top, the side, from the side. What you don't want to do is when you click to have it jump to the middle or an anchor point. And so this is why I track the difference. From wherever they started clicking to wherever they move, I track like the distance, and then I can move the thing accordingly. This also means I don't even have to know where the anchor point actually is for that difference, but I need to know it for other reasons. So I have that difference, I have the point, and now I'm going to do a clamp point to bounds on that new position with this anchor pad of the object I want. This is the object being trapped, and for these ones, it's going to be the width of the object, 0, 0, width of the object, and clamp point to bounds. Clamp point to bounds. Very simple. When I stored the bounds before, call clamp on it. I had to add the clamp function in JavaScript. It's right here. If you've done any graphics programming, you will recognize the clamp function. It is very, very common. It's unfortunate that linear algebra functions are not part of JavaScript or TypeScript. These are these ones here, v2 add, v2 sub. I've written these like 1,000 times, and it's unfortunate I always have to write them again. So the clamp point to bounds really just takes a point and ensures it's within these bounds. And this anchor pad thing, it puts padding on. So you see this object, assume the anchor's in the middle of it, like right on the nose of the sun. Well, the bounds of this board are actually right up to the edge and right up to the edge. But we don't want you to move it right to the edge, because the moment it comes to here, it can't go further. And that's what the anchor pad is. It says, actually, I have this much space on the left, and I have this much space on the right, and I have this much space on the top, and that prevents me from moving it outside. Now with a circle, the padding's all the same, but for the books, it's a different case. And it also allows me, by having a full rectangle of anchor pad, the rect4, it lets me have irregular shapes. And as it turns out, these really aren't circles in SVG. It ends up being the anchor pad is 0, 0, and the anchor point's right up here. And so that's where the anchor point is. And so that's just that normally in SVG, you generally only have the anchor point 0, 0, or for circles in the middle, and there's no way to specify anchor point otherwise in SVG. So that's the first thing I do on mouse down. We convert it, and I clip the point. Very simple. Mouse moving, I mean mouse moving. That's what happens in mouse move. Clip it, move it, and then basically I set the new transform of it. And this is CSS, sort of. There's a weird line between SVG and CSS that its style properties are specified as CSS. This doesn't mean all CSS applies to SVG, but that's the way we do it. And so literally this is what I do. I just set the transform of this object to be that new position. Translate position px, position px. And you create a constraint here, add this string. It's a horribly inefficient interface, but I don't have another option. There might be XY attributes, but they work a bit weird, so I'm just going to leave this. And even XY, you'd still have to put the pix. So this is an annoying thing, an inefficiency in the browser that basically I'm going to produce this string and it's just going to parse the string again. And that's the only interface we have. Given how much I'm moving it, it's not an issue here. But when you animate other objects, this overhead become an issue because a few hundred objects to parsing and generating does actually start adding up in time. And so now you can see it at the bottom, whichever one I moved. Let's inspect the element again. You can see the translation string wherever it was. There we go. It's actually right there, transform, translate. It's actually in the style. You see how I assigned it to the style and the transform, and that's the actual string I put in. Exactly where is it? That may not be, this is actually their generated string. They've parsed mine and generated it. And so that's how I do the basic moving. The basic moving just works like that, and that's how I clip it to the bounds as well. What next thing happens is on mouse up. What happens on mouse up? The first thing is cleanup. Well, first thing is I get the current point again, and this is a clip point, and then I release the pointer capture. Please don't forget to do that, because otherwise your user's page is going to be non-responsive and they can't do anything else on it until I clear it away. Then I do context clean. That was the function I set up before, which undoes all these things like all the listeners and all the classes. It just gets rid of them. So we're back to a clean state for the UI. And then I do this bit here. At a high level first, this is going to do the clipping and then send it off to the game as messages. Remember, I don't have a directly modifiable state in my game. Everything goes to being messages because it's a multiplayer game, so anything I change has to be sent to other players and changed there as well. So instead of just modifying the position, I'm going to end up creating messages that modify it. So during mouse move, while I'm moving, basically no other players see that I'm moving it. It's only when I release is when the permanent state gets changed. That reduces message flow. There are other ways to do it, but I'm going to keep it that way for now. And so what are the messages I have to send? So there's two different types of containers. This is what's known as a deflect container because if you drop on stuff, it deflects it. And so I call a function called target drop. Should be called target deflect. Let me actually do that. Target deflect. Deflect. Target drop now becomes target deflect. And this is the part where the weird stuff's going to happen. It's not actually going to be deflecting first. A few setup conditions, for all of the targets. So this is the most important part. The targets is the one we're going to look at first. I'm going to get the objects, and then I'm going to get the shapes of all of them. I don't know why I call it a container. These are target shapes. So what are the targets? The targets are in these flag shapes here. The one, if I move the Canadian one up here, it moves in there. You notice how it slides into place the moment it's close enough. The reason I do this is because if you're doing the game, you don't want people wondering, well, did I get it close enough to the middle or not? So basically, the moment it's close enough, it snaps into place. So it's very clear you got it in the right place. This is something I wish would happen in physical escape rooms. It's way too often in physical escape rooms where you get something like right here and it doesn't register it's in the right place or over here. And it's something if you're doing live rooms and live puzzles, take care of to make sure the user doesn't have to be exact. And I'm taking care of that by snapping into the exact location. And that snapping is done here. I get all of the shapes and I call something find closest center, and I'll go back to that. Find closest center basically says, all right, I have the closest one. It gives me the index of the closest shape. And it says index is not null. This is just some TypeScript testing. I know what type it is, and it's going to say, this is my drag target. So find the target. If I have a target, that means if I've dragged onto a target. If I've not, it's going to be null. So if I drag onto the target, it's going to be non-null. And I get the bounds of my element now, my element. And I compare the distance between the two. And I'm doing something very rough here, doing the width and the height. And this is the minimum distance. So if I take the the width plus the height and a quarter of that, if I'm that close to the target, then I'm going to snap into place. This is just something that I played with visually that makes sense. And I'll probably have to adjust it in somewhere if I do other shapes. So this is a standard loop. If you've done any interview algorithm tests, you should be used to such a loop where you loop through and you find the minimum distance for something. And so the minimum distance, I just find it. And this is really just take the distance I have, do subtraction between my point and the distance, however far I actually am. And that's the, so first off, we already found the closest center. Sorry, I screwed that up there. We already found the closest. I'll go back to this. And this one just says, if I am that close, so this is the closest target. And if I'm within a certain range to that target, then this position here actually snaps to that target. This center offset says this is where I'm going. So the loop basically is find the closest, and if I am close enough, snap it to it. Because obviously if I do this, it's going to find this as the closest shape. Because, you know, that is the closest. But it's not close enough to snap. So it's only if I get close enough to the center does it actually snap. And a note about that, it's not actually snapping to those shapes. It's snapping to other shapes on top of that. This will be, oh man, I have so many of them. Where magnet word. In this file I have, you'll see the shapes it's actually snapping to because there's ones that snap to other locations. Like that flag over there, it snaps to over here. And obviously it doesn't know to snap to the middle of the flag. So I have these circles, and these circles inside here are marked with a drag target class, which is going to hide them while rendering. but that's the one it's actually snapping to. So in the dragging, it doesn't see the flag, it sees only those circles. Those are the actual drag targets. And so it says, if I'm close enough to that, snap it into place. And then something weird happens for deflect. But let's first look at the get closest, find closest center shape. That's actually not a very difficult function. Find closest center says, this is where I'm at, this is the position my object is, and this is the position of all the centers. And I'm basically assuming center is the place I want to see how close I am to. And this is what I said, this is a standard algorithm loop. If you've done any algorithmic challenges, any coding interview challenges like that, you'll see this. Basically, for every object I have, go through, calculate the distance between the 2 points, and if this is less than the current distance, then that becomes the new closest item there. For the number of targets I have, this is completely sufficient. If you're doing a game that has hundreds or thousands of targets, you have to start worrying about optimizing this algorithm to not actually compare to every single object. There are ways to drop this down to have lists, to have trees of lists where you'd group them. The standard is to group them so the objects on the screen, for example, I'd have this screen divided into 4 sections. Up in these 4 sections, a quarter, a quarter, a quarter, and these flags would be in each of them. And then I compare to the top quarter, which quarter am I in? And then I compare to these ones here. And so that would reduce the count as basically instead of 12 comparisons, if I broke into quarters, I'd only have 4 plus 3, 7 comparisons. So you can actually reduce it down a lot. And you can break the tree down quite a bit. So if you just did halves and halves, you'd have 1, 2, 3 comparisons. Because I only have 12, I don't care. I could do it because my targets are entirely static. But since I don't know the position of them until the user starts dragging, it doesn't gain me a lot because I'm going to have to calculate the position of all of them anyways. So I just do it for all 12 of them, and that's fine. And so that gives me the location there. It finds me the closest one, I snap to it. And that snapping is actually right here. This is just some of the message code in my game. It sends 2 messages. You'll notice the 2 says I should have this as 1. It sends 2 messages saying set the position as 0 and 1 of whatever position this object is in. And this is the X position and Y position just as here. So I sent 2 messages in the game message saying I'm modifying location. The game engine doesn't actually understand its location, and I've done that personally. So the UI understands that there's a position object on this, and it translates the position. The game engine itself does not understand these are positions. It simply knows there's 2 values here. Doesn't matter what those 2 values are. That gives a lot of flexibility in the multiplayer engine. It just deals with more raw values. Okay, now I'm skipping over this bit, but I'll go back to, actually, let's go right now. In order for this game to determine if you're in the right place, like here, that's wrong. Here, that's right. How does the game actually know that that's right and wrong? You know, you could check the position of the maple leaf and compare it against the location of that, but that gets super hard to program with and very error prone. So what I actually have is I have a list of values stored in memory saying which object is stored in each position of the flags. And I can show this a bit better with the books when I get there. For now, it's just, I think I have an array of 12 values, 1, 2, 3, 4, 5, up to 12. I have an array of 12 values, and each of these has numbers. Canada happens to be 0, Japan happens to be 1. So what I have is I'm going to have a sequence of 12 numbers, and as I drag them, I update that. And that's this message here, something called move index. And because I had this cont target, it knows where it is. And here's a bit of trickery here that this target refers to an index in that array. So the target has the index of the array where it has to modify it. And this move says wherever it currently was, store the new one. Because I can't just set the value, I have to make sure if it was over here and I move it here, that this one is set and this one is cleared. So this is back in the game engine, but basically it's the target that says what index am I in this array, and then it's the drag object that says what value it has. So the combination of this value plus this target can update the array. And then the game engine can simply check for all correct. It can just do a comparison of the 12 arrays. Are all the items in the right place? So now the last little bit I didn't have to add. but I wanted to add was the deflection. When you go like this, it moves one out of the way. It's because a lot of these games that are playing, the online ones, they have this. You can have items that start overlapping, and it gets a little bit annoying to have overlapping items. My deflection isn't perfect, but it takes care of those basic cases where you want to deflect that. Now, there might be some where you don't want to deflect. This is meant to represent like a real-world object. These would be magnets, and the magnets can't exist in the same place at once, so one of them has to move. But you notice here it's not perfect because I can go over there. It can move multiple ones, but it can only move from this one. It doesn't do the chaining. If I do this, it won't chain move that. Eventually I'll improve this, but that was enough for now. So the way it does this is it calls a Deflection Shapes function. Let's just go there. The rest of this stuff here is simply updating the positions in the game engine. That's the exact same thing this does here, but here it just moves them around so the game engine knows that something's been deflected. But let's look at Deflection Shapes to get an idea of what this algorithm is for deflecting shapes. Prime shape is the object I am moving, and the first thing we do is we find all the overlapping shapes. And I passed it in a list of the shapes. We've already seen getting these shapes. And the shapes have like a box and a center and an anchor to them, and I just get them. So with those, and you'll see the note, assuming it's circle-like for now, which is fine because all I have is circles in the game. The moment I make a new game, I'm going to have to change it for other shapes. Intersecting circles is the easiest shape to intersect, and you'll find a lot of game engines actually represent their characters first as a circle to encompass the whole object, and then define details. Because if it's not within the range of the circle radius, you don't have to do the costly polygon checking. Mine happen to be circles, so I can just get away with that. To check if two circles are actually intersecting, all you have to do is calculate if their centers are closer than a radius. So here, the distance between them is greater than the two radiuses, which means they don't touch. At this point, the distance between the two centers is less than the two radiuses, so they must overlap. And this is all this is doing here. And it's keeping track of all the ones that have overlapped. And for the overlapped ones, now the question is, what do I do with them? Where do I push them? I took a simple approach of just saying, well, wherever they intersect, they have a line where they intersect. And you can see it points to a vector direction. And I calculate that direction, the direction between the two centers. So here the direction is this way, and I move it along that way. Direction is a normalized vector, so all I have to do is say, along that direction, how much do I want to move? And I guess the radius of both of them. Now the radius here is a really stupid calculation. I don't know the radius. I have no way to track it for that shape. So what I make the assumption of here is wildly, it's the average of the width and the height, which for a circle happens to be the radius. For other objects, yeah, no. So when I make another object, I'll have to get back to this. So once I have the distance I want to move and the direction, I simply add and multiply, and I combine this into one function for efficiency, and you'll often see engines that do this as well. I take the center of it, the direction, and this distance. And this is a linear algebra operation that takes this plus this times this. And then it clamps it to the bounds, right? Because if I'm down here and I move it out of the way, I don't want it going out of bounds. I live with the overlap instead. An optimal solution will move this over here. That gets a bit more difficult to implement, but I eventually will. And maybe I'll do an update when I do that, but that's be more math heavy then. So there's the new result for each item that overlaps. And this is like I say for each one, because you can have multiple overlaps. For each one, it scatters them. You can actually have 4 of them actually. I wonder if I can get all 5 of them in here. I won't actually overload 5 of them. Yeah. So it moves them all out. And then it returns the new positions, which get translated into messages. So that was a lot, I know. I just wanted to talk about all the high-level things I did, how this is done to give you an idea of how this is working in code. This probably isn't enough to go by to actually write the code, but if you're adventurous enough, it would be. It just gives you an idea of how that works. So I want to go and check the other one. What's different about the other one is the books. The books don't have targets. There's nowhere you're dragging them onto that they're going to snap to. What the book has is a kind of a gravity system. I move the book in between, and that's the new order of books. Most of the code here is the same. It starts in the same code for pointer down, it sets it up, and it moves it. Moving is exactly the same. Moving is clamped within a region here. I could make it wider, but then the books might not overlap. I had to make it enough so they can always overlap, so that they theoretically stack that way. What difference is in the final when you move the mouse up? What happens then? And this is now I have the stack type, and I go to target stack instead. Target stack. Target stack is actually a lot easier to implement. There's no real deflection here, right? This looks like I'm deflecting everything. If you move a bunch of stuff around, it looks like, oh, wow, it really knows what it's doing. And it's actually a lot simpler than that. All it's doing is when I move this down here, it calculates the center position of all the books. And then it orders them by center, and then starting at the bottom, it stacks them back up. So it's really straightforward. It may look like it's deflecting, but it's not. It's just doing a new stacking. And so that's a lot easier to do. Again, I map for each of the objects, I get the shape of the object. And again, I have to do the shape. Well, I don't have to do the shape. I do the shape dynamically in case something has changed. Theoretically, because it's contained within this box, the position and stuff shouldn't change based on like scaling and stuff. Practically, there's a few defects in SVG and the browsers that make it not necessarily true. Let me get back to it right afterwards as a defect thing there. And then I also just say so basically, ignore it, just go on. I get the shape of the object, which are the bounds of it, like the bounds of the book. And I also get the center. The shape function also returns me the center is the anchor point, or it tells me this is the center point that I'm going to compare. And then for each of the objects, I'm going to say, well, my ordering is based on the center, and you see I take center 1, which is the Y offset. This is hard-coded for a vertical stack, so it only considers the Y point when rearranging it. There's a special case here. If I have the actual object passed into the function, I use the provided position because the position in SVG doesn't have that value yet. So I have to use the new value. And then I simply sort them. There's a JavaScript sort function, sort them by height. And now there's something called a base object. So I have them all sorted by height. Now I need to stack them up. But where do I stack them? Well, there's a table down there. They always fall and start from that table. And that's what this source container is. This is encoded in the level of the game saying, look, this table is where they're going to stack. And so I get the shape of that, and I get the top of the box that says this is the stack anchor. And then for each item, in the order of the drag shape, I start at stack, and then I go to stack anchor. So I start here, and I skip up here and say, well, the first one has to be positioned up here. And then I position it up there. And each time I drop the stack anchor, the height of that book, it moves up the height of the book each time. All these books are the same height, but this algorithm would actually work with different sizes of books because it's taking each book dynamically and stacking it. And I'm tempted just to make them different sizes, but the same size actually I think is reasonable. Otherwise I had to change the artwork and all of it. I initially did the same size because I thought it'd be easier to implement, but as it turns out it's just as easy to implement different sizes. And this is the message again that basically says set the position of it. And then overall there's a stack value to this. And this is what I mentioned before about I don't want the rest of the game engine to have to worry about the positions of these things, only what value is here. Logically, what are the order of these books? And I actually have a debug interface to this where I can actually do this game manager. Game state. No, it's actually just state, isn't it? Just game state, sorry. Dot vars, and the vars are books values. This is where it ends up. You can see all the values in the game. And, okay. And you can see it lines up. So scarlet, green, orange, yellow, violet, blue. If I move these around a bit, I already did checking here. Logically, I have now, if I look at the value again, yellow, blue, violet, scarlet, green, orange. So those are the important values. The game engine doesn't care about the UI here. It's just saying, look, all I have to do is check the order of the books. And this one's actually based on color, and part of the joke is that they're in black and white, but the titles have color in them. And so that's how it does the stacking. It stacks up those values and pushes them, and it sends a message also to all the game pods that says, here's a new stacking order. If there are multiple people working on this, let me check this actually works. They should all see the same order. Let's go back to Chrome. I just use Chrome for this one, so I have a different tab. Let's go to the books. So he should be in the right books now. If I move like a book, you see it move over there as well, right? These are the books that are moving. And over here as well if I move them. And it'll have the new stacking order here as well. Violet, blue, yellow, green, etc. So these are the two. This is how you can see that it's actually networked. And these are why the messages are important. So the message is what actually changes the game state. It works on both of them. If you have two players who pick it up and drop them at once, this is where the weird thing happens, that one of them is going to win. So the first person, if the first person suddenly comes in here and changes the ordering of this, then it's going to take the new order and it's going to have the different height. So if two people happen to move something at the exact same time, there can be an issue. The same with the magnets. If two people move at the same time, the issue being it might not end up where the person thought, but the critical thing is that it'll end up in the same state for all of the players because there's a fixed ordering to these messages and it'll take that fixed ordering. So even if it jumps around for this player, then at least it's the same order, and the players will recognize that. What would happen in real life? Well, in real life, it wouldn't happen because actually in real life, if you play an escape room, you'll know what happens if you have two people messing with the same stuff. Just scattered, you can't tell what's going on until you tell the people, stop, let me move them around, and it should be fine. And that's how the messaging works. Couple notes about the technology here, about the SVG again. So again, the key critical objects here, I had that get shape. Get object shape, I call that a lot. And that's the boundary between my objects and the SVG world. And it's this get object shape function here. And the first thing it does is called this.getBoundingBox, which is the actual SVG box, get bounding box. So this is the tricky part. This is the SVG part. And this is the part I can probably put a snippet in the comments or the article I write with this to show where this is. So go over this carefully if you want it. The core function is this get bounding box. This returns the bounding box of that element. It's weird. Relative to, well, that element. And that's where it gets really weird. Actually relative to the parent element, but not completely. So there's a weird thing here that says, well, okay, I don't completely know if it's relative to that element or its parent, but what I do know is that if I call element get screen CTM, it'll give me the matrix that translates these values into screen coordinates. So whatever the values in here are, I'll translate them into the screen. And then I'm going to take the same thing I did with the point reversal before. I'm going to get the transform from my viewport, invert it and multiply it by that. So this effectively gets me this bounding box within my viewport. In theory, this is where there's an SVG problem here. In theory, there's a function called getCTM, which is supposed to take these coordinates and translate into the coordinates of the viewport. But it doesn't do that. It's giving me some other value, and I don't know what that value is. So the way I get to the viewport is I translate to and from the screen entirely, and that gets me my viewport coordinates. I have a feeling that this one wasn't specified to consider scaling and aspect ratios, and so something's broken with it. So this function, I don't know what it is. I can't get a useful value out of it, so I ended up using this one to and from the viewport. Is it less efficient? Yeah, well, not really. It's just two matrix multiplications. Well, it's actually a bit more than that, but it's really trivial. It's not a big deal. There's an inverse here, though, which really sucks. If you can avoid inverses, it's great. This one would avoid the inverse, but it might have internally. The inverse is hard to be a problem if something starts to become really, really, really small. I mean, you can never make this browser small enough that's going to be a real problem. This should still work here just fine. But if you had something further inside here, inverses can be an issue. But for the most part, my game's not going to exercise them. If you have a 3D engine and stuff, and you have small details in a very large world, you have to start worrying about the precision of these values. I don't, so I don't there. But I'd like to, I'm still curious as to what this function does get CTM. It does not do what it's described. It does not give the points in the viewport. This gets the values in the viewport. Now, to get the bounding box, I have to make an assumption here. No rotations and no skewing, which is okay because these objects aren't skewed and they aren't rotated. If they are rotated, the entire set of algorithms here becomes problematic as to what a collision is, what the stacking is, where's the Y order. So for this version of the game, I'm assuming they're just not rotated. And then I pull out the matrix values from this resulting translation and multiply the box directly for it. You can't just there's no multiply here that gets this. I have to actually manually do the translation here based on the bits of the values here. I mean, I guess I could encode it as a point, but it's just simpler to do this. Another weird SVG anomaly, and this one is really stupid, is that if you have a 2D matrix, the values are encoded as A, B, C, D, E, F, which is a stupid naming convention. As opposed to if it's a 3D matrix, you have the correct names of M11, M41, M24, M22, the logical named values. I don't know who decided this. This was a bad decision. This is just stupid that you have completely different names. And like I say, A, fine, it's clear A is 1, but the moment you get to B, it's not clear what that is. Whatever. So that's one of the limitations here. This translates my bounding box. So now I have to create a DOM-rect read-only from rect. The reason I do this is because my older code used the DOM-rect, and so I'm just using it to simplify it. And this gives the XY width and height of that rectangle. And in typical JavaScript fashion, this is extremely inefficient compared to a AAA games engine that would be full screen with 3D rendering, where most of this stuff would really not do much at all. Maybe this gets optimized away, I don't know, but this is actually storing things by name, and then reading it by name and creating a rect from it. Whereas in an optimized engine, you would just store the 4 values. If it ever got to that, I'd find a way using like a WebGL to optimize this. But again, I've got 6 items here and 12 in the other one. Yeah, it's not a problem. There's just not enough problem here to make a big issue. And most of this code is compiled. So these are high-level functions I call, and internally I assume they're optimized. So to get bounding box, that gets the bounding box, and that's the basis for the object shape. And then the object shape, this basically assumes a rectangle or a circle, and it says, well, what's the center of it? What's the offset from the top right corner? And where's the padding for it? This abstracts my code to deal with other shapes in the future and other anchor points. Right now, it just assumes rectangle, but what it means is the rest of the code calls get object shape, and it gives it all the details they need without them having to think about where's the anchor point, what is the actual shape of it. So that's the overall structure of the code. That's how everything works. This is the SVG element is very isolated, and to get bounding box and getting these transformation matrices. And they have 2 different forms, the stacking. And again, the way the stacking logically works is as I move it, it just calculates the center position of all of them and restacks them starting from the bottom item here. And these are all SVG. And again, it sends everything as messages so that it works in both sides of these things here. And you can move them while they're moving it. It's just I'm not going to get fast enough to switch there. Doesn't matter if some glitch happens, they'll both end up in the same final state. And the magnets are here too. They move in the same fashion. They have the same fashion. These are also just the same messages. You can see the same messages doing the same thing to be the multi-client one. And these ones are using deflection. Deflection if they hit, and they also have targets. So if they snap close to a target, they snap into place. And that's to make sure the user knows about it. And they both set variables internally saying what order these things are for the game engine to work from. All right, I know that's a lot. I just wanted to go through this as a basis for people that are like writing new games just to give you an idea of where you might start and seeing some of the ideas behind it. And if you have questions, feel free to ask, and I can answer them in article form or post as a comment, and I'll post it over maybe on Dev2 as well, on my blog as well. Just saying, look, I did these outfits together. There's no point giving you this whole code, because without the rest of my code base, it'll be very hard to make use of any of this. But that's the general. I just want to show you how some of it works, and hopefully this helps you on your own adventures with drag and drop. And again, this is all SVG, HTML, CSS, JavaScript. There's no canvas here or anything like this. This is just a pure browser rendering that does all of this. All right, that was a lot. So again, this is all going to be for an upcoming game called Office on edA-qa's room. So I have Prototype now, which is my original one. We have to get a room in Carnival. You have to find the Secret Society. These both use the same engine. They don't have the drag and drop puzzles, obviously, because that's a new technology. For each game, I intend on introducing one basic new technology and then writing a new game around it and using the existing ones. And it's not the technology that makes the game. This just opens up the options I have for puzzles. So I had plenty of puzzles for these ones. This opens up a few new styles of puzzles that I wanted to do. And it'll just make it more interesting, but I'm going to reuse all the existing puzzles as well, because there's lots of other techniques in these puzzles, lots of other things I can reuse. Like clicking in order and stuff there, that was already existing. And so I'll keep doing some more of these videos showing how the game works. So if you have questions, I can answer it in a future video in the article. Otherwise, have fun with SVG and HTML. Don't go too crazy with the SVG. I mean, in terms of Sandy, it's hard to work with. There's a lot of issues in the browser, and there's a lot of weird things that happens. But okay, in any case, thanks for watching, and I'll go back to developing my game now. All right, have a nice day.